Fritz, Managing Director of AC-DC-HOTLINE. I'm based in California, United States. And again, I'd like you to join this group if you would like to, about Nikola Tesla's collaborations. He was the original one that designed the AC induction motor, which uses a tremendous amount of power. A little bit of history about myself. I'm second generation. My father is shown there. He started in wind charges in 1953 and then went on to build several electric motor repair and design companies, got into manufacturing, manufactured a lot of fans, pumps, blowers, those types of things. And then you'll see on the right-hand side, that's my fourth generation grandson working in one of the panel facilities that are in the Midwest that are owned by the family. I've spent a lot of years in this industry. I've worked very closely with a lot of the power companies to help introduce this technology. Part of the presentation that I have today is actually from various webinars and things that I've given for the power companies. The other area that I've spent a lot of time in, I've worked with EPRI, the Electrical Power Research Institute, in 1995, where we were offering adjustable speed drive research to be put on injection molding machines for improving efficiency of the motors. And it was a very successful. There have been now thousands of machines that have been retrofitted, and they do save a lot of power. These technologies we're going to talk about today were originally kind of developed back in the 80s and in the 60s, actually. There was a fellow called Nolan that first patented the for NASA. He patented the soft starter, which would basically, we're using SCRs to bring the motors up to speed slowly. And then he also went on later and worked on the variable frequency drive, which is put on induction motors today. Looks like Barnaby's having a little difficulty getting in. It's just the connection. And I'm going to go ahead and start. This is a little bit so you understand. I've done a lot of research with Nikola Tesla. Extremely brilliant man. This is a little pieces of who he really is, if a lot of people don't know.
When you think of electricity, you think of Edison. But there is one electrical genius who is nearly forgotten. A man who dreamed of giving the world an unlimited supply of energy. His name was Nikola Tesla. This is the story of a modern Prometheus who changed the world with electricity. It was Nikola Tesla who captured the power of Niagara Falls with his alternating current system and made it possible to transmit electricity to all of America and the world. Suddenly knew he could recreate this rotating field by powering the coils of a motor in different steps or phases, like the pistons of an engine. The resulting forces of magnetic attraction and repulsion would literally twist the rotor in a circle, the electrical equivalent of the wheel. And all this was accomplished with alternating currents. It would soon turn the wheels of industry around the world. Tesla was ready to unveil his motor to the world.
So the reason I brought him up is because he's the one that originally developed the AC motor. Edison had developed the DC motor, but it had brushes and a little bit more complicated machine, obviously. There's advantages to both. The electric motors consume about 70% of the world's power, electric power. And with the impact properly, I believe, with controls, variable speed drives, SCADA systems, which are basically so you can turn them on and off when you want, even clear down to your cell phone today. That there's a great opportunity to save power. There's still a tremendous amount of motors and machines out there that are operating, but they're running at a fixed speed, and they're running at that fixed speed. It utilizes pretty much full power. Are some people having trouble with the audio? They can't hit. Let's see if I got the audio on. Can everybody hear okay?
Yes.
Okay, I guess somebody might just have a problem, but thank you. Yeah, so the global, energy consumption sectors is that, about 51% of the motors go into motion. About 19% of the motors are on fans and pumps that are in HVAC. And then the other utilization of power is electricity is like about 16%. And then IT and electronics is roughly about 14%. So the key is that a person needs to understand the actual motor lifestyle cost example. So if you purchase a motor, it's only really a fraction of what the cost is compared to what its operating cost is, and operating. So this is at electric cost of about 11 cents a kilowatt hour. So you can see over a 10-year period that it actually costs about $45,000 to run that motor. And it only costs you $450 to do it. So it's an area of understanding that the utilization of where your power is going in your facility is very important. Let's see if I have a couple of the notes we're going to read. Okay, they got the audio going. Okay. So what the variable frequency drive defined is basically an electronic package which connects the motor, which has capability of controlling that ACO motor. They're designed similar to also even they utilize these transistors and items for under power supplies. They convert that fixed speed supply motor to variable speed, and you can then control the torque and speed of the motor, where prior to that the motor ran one speed. So what he was showing in the video there is that there are coils that are in the motor that as you produce the alternating current to it, it creates a north and south pole in here and then makes the motor shaft rotate. Well, when we provide it, like in America, 60 cycle power to a 4-pole motor, it ends up running at the synchronous speed would be 1800 RPM, but it's like 1725. It doesn't change from that speed as long as this frequency is the same. And so it's very complicated for years to, figure out ways they can vary that. The only way you could actually do that would be to slow the generators down and slow the sine wave down coming from the rotating machine. So in a power circuit, you have 3-phase power, which is most industrial applications. And you can see that there's 3 sets of sine waves. There's phase 1, phase 2, and phase 3. And those are feeding into the motor. So you actually have 3 sets of coils on each one for each phase. So this would be more like a single phase showing machine, but a 3-phase would have more coils crammed in here. And then they rotate that field. So when they came out with which was Nolan came out with the variable frequency drive, what he is basically doing is taking the sine wave power that we get from the power company, and they're converting it to DC power. And then with the DC power, they have these filtering capacitors, and then this is like what they call a link choke inside to basically just slow down the electronics so you don't get a lot of real surging in power, is what links do here. Sometimes they'll put a link choke here, they'll put line reactors out front just to help for surges and pulses. And then with IGBT transistors on the backside, they're refiring what they call PWM. So it's actually not a totally true looking sine wave. It actually has pulses in here. And there's some factors that you have to be, aware of when you're doing this. And that's where you get, issues with motors and that stuff. So it's good to, definitely know what motor you have and, what's going on. So as you can see here, this is like the power coming into that grid, and you can see the actual current flow going into the motor or into the diodes themselves actually feed it pulses, because what they're doing is they're recharging and filtering this DC bus power here so that this stays like on a 480 volt machine. This is about 760 volts DC here, and then they're taking that and refiring it out. But you can see that so this is what the input pulse looks like, and it will, give you this input, but you have to be aware of when you have like multiples of these machines all together, because you get a lot of pulsing, you can get some jagged, and that's what they call harmonics. So there are, things you want to check when you're, go ahead and installing drive controls, that they're, correctly, set up correctly into the circuit. And there's some back checks you can do that will, help the longevity of not only the inverter, but also the motor. So you can see here that if it's at 30 cycles, meaning 30 cycles a second, that means it'll take that 4-pole machine at 60 hertz power, that'll make it run at like half of the speed. So we're controlling, and you can go down to even 10 hertz. You can see the pulses. And so the one line here is the current waveform. The other is actually the voltage waveform. And so it's also important, if you have longer lead lengths, that you're careful on the outputs, not to have, you'll get some resonance, because this is, again, not a straight sine wave. It's a PWM, and it'll actually can over voltage the motor. So I give other classes, which I think I have another one coming up February 2nd, which is specifically about, why are my electric motors on pumps failing? You're welcome to join that one too. And I go into much more detail on, just different applications for that. I also utilize quite regularly these Fluke 430. I have a 434, that's a little bit older version of this one, but these are kind of expensive meters. But there's a lot of advantage to getting the right data of what we have to begin with. And I'll just start this video, and we can go just briefly into it, but it'll talk about it. So.
Introducing the Fluke 438 Power Quality and Motor Analyzer. The Fluke 438 is a multi-purpose test tool designed to improve troubleshooting on electric motors and minimize downtime. Whether you're in a process plant or discrete manufacturing, electric motors are critical to your operation's success. The Fluke 438 lets you quickly gauge electrical performance, power quality, and mechanical performance of industrial motors. Using 3-phase electrical measurements on the input and motor rating plate data, the 438 calculates torque, the most critical mechanical performance variable, speed, load on the motor shaft, and overall efficiency, without the need to install mechanical sensors. All this with a single tool, and all while the motor is running, so you don't sacrifice uptime. Power quality issues, such as unbalance and harmonics, can cause motors to run hot, eventually stressing windings and accelerating failures. Motor failures lead to costly downtime, and the cost of waste associated with inefficient motors adds up. When testing direct online motors with the new Fluke 438, you get both power quality information and mechanical performance data in the same test with a single tool. With an intuitive user interface, optimized current probes, and at-a-glance motor status screens, the Fluke 438 gives you the motor troubleshooting information you need to make better maintenance decisions and keep your plant up and running.
So the reason I bring that up is that when you are looking to put in variable frequency drives, which do have the advantages, they will reduce the electric cost if it's on a variable frequency pump or on a pump. It can be cleared out at 70% because you get the cube law factor in the pump load. But it's also important to measure your process, of how much water, how much flow that you're actually truly needing. They increase the motor life when they're properly installed, and they'll basically also improve process, better control the flow, pressure, torque, acceleration, deceleration. And then there are a lot of utility incentives around the world that offer energy. And if you want to send me an email from where you are and what you where you're at, I have access to some very large databases that show what they give for incentives for implementing this kind of technology. And some of the areas that are good applications, all types of fans in a building, in air compressors, chillers, cooling tower pumps, vacuum pumps, and then on larger commercial applications, all kinds of exhaust fans, some process cooling, again, all the different types of HVAC motors, and other large equipment that is driven. When you control that frequency and voltage to the motor properly, it does dramatically reduce the actual amount of power consumption. Some of the other applications in industrial are conveyors, presses, casting equipment, injection molding machines, which I'd spent a tremendous amount of time in the 90s and 2000 on this industry, and have retrofitted thousands of machines to conserve energy. And that's why the Electrical Power Research Institute has done a tremendous amount of work of reviewing this technology. But when people are trying to look at it themselves that don't work in it every day, it kind of becomes a little daunting to, what do I do? How do I do it? I'm glad if you want to send me a listing of like motors and, what the applications are. I can really help you find what I call the low-hanging fruit opportunities. And we've done a lot of work in municipal water, pumping systems. I'm currently working a lot on irrigation pumping systems and things where I live in California right now, and on the pump stations and water and wastewater. So what we're talking about is where on what they call variable torque, or air handlers, pumps, and those type of things, you actually get the cube law, so that a lot of people utilize leave the motor at one existing speed, but then what they do is they just damper it with a vane. But you can look at the typical power requirements of it when you do it by just dampering it. It only drops down to about 60%, but at the same spot, if you did it with a variable speed drive and slowed that fan down to that same amount of speed or same amount of flow, the horsepower drops so tremendously because the motor continues to operate and run, and continues to use a lot of power. And so centrifugal fans, pumps, blowers, those type of things are definitely very good applications. Like even up on a lot of them are going on rooftop air conditioning systems now, where they're putting it on the VFDs on the both the inlet and outlet fans, and they're also putting VFDs on even down to the compressors, controlling the compressors and controlling them back to temperature instead of, running it. A lot of it before, they were utilizing, belts and pulleys to get it, to run the optimal speed. When the engineers would do it, they always have to give themselves a service factor. So most generally I see about 125% service factor. So you end up running the fan and the pump a little bit higher than what you need just to get it out, and then you damper it, with a, with some sort of a damper. They also use chain sprockets, gear reducers, variable pitch pulleys, and then variable frequency drives, can also accomplish that power reduction. And then they size the motor for, maximum flow, and then they use, throttling devices to reduce that flow, and, those with valves, dampers, and et cetera. So inside, buildings, and, you'll find, several valves, and a lot of times those are turned down, to maybe 30, 40, 50%, flow through, but the motor is sitting out there pushing full power. Or, they have dampers in the system, and they're dampering the output flow, but the fan is still running over there at full speed. So, the annual savings, with and without a drive, this happened to be a case of a 19 kilowatt savings, that had a, pretty good return of almost a $20,000 savings, and that was on a 50 horsepower motor. And when they put it with the VFD, we were able to save almost $20,000, over the 5 years, which is back to the, loss factor in the motor. So variable frequency drives, applications for consideration, is, the horsepower, varies with the cube. You got your torque, is the square of the rotational speed, and these are all on, these pieces of application. And if you can control the lower of the speed, then you get the, power reduction. Constant torque loads, typically your torque stays pretty constant on it, so you don't get the same power savings, but a lot of times you just don't need to be running that grinder, that mixer, those compressors, at the same rate of flow. Or if it's a compressor that has, valves on it that are actually shifting, and loading and unloading the compressor will run the speed. A lot of new machines today are, implementing this. Even a lot of the new HVAC systems, in my house, even we've got a variable speed drive running our compressor and our, fans and stuff outside, inside into the house. So what I was talking about is you've got a constant torque load and then a variable torque load. And what they mean by that is a constant torque load is a load that doesn't change with speed. So it has that same amount of, torque requirement to move the materials, but as you speed it up, it increases in horsepower requirement than it does at lower speed. So a speed control can help that. The variable torque loads are, again, we talked about that already, have the huge savings. So again, inside the buildings, you're going to have a lot of, blowers and fans. And the reason why they don't, get brought to the front of the energy, look all the time is because of they're hidden. People don't always go down into the control room. They normally go into a building, and they see the air conditioner and stuff bringing air into the building, but they don't realize that there's a large motor down there that is actually producing all that airflow into the building. Well, as you need the demand, you need to control this. And then there's various types of pumps that are, operational, that run at variable speed, that also can. The issue on pumps, you have to be very careful though, is that you watch where is the sweet spot of that pump and that impeller to produce power, so you don't get off the pump curve. So this is, typical, differences between, at 100% flow rate, with outlet dampers, you'll see that this is where the curve goes here. And then when you put the VFD in, you can see this differential in power here, and it becomes, quite dramatic in power, and that's both in fans and pumps. Again, this is a little bit more on the pump curve. So what I was talking about is there's this affinity law, which is basically flow versus speed, and it actually gives you the amount of savings, and then you can look at your head versus the speed, and then the horsepower versus the speed, so these were some case studies that I had been involved in over the years that were, fairly dramatic in, where there's opportunity for energy savings. This happened to be a case study of actually a dry cleaner that was utilizing, cooling for their systems in the building. They were also using a lot of pumps and fans to run the cooling or the cleaning facility. And so we were able to secure a $31,000 energy incentive for them, for the customer. The annual savings was about 171,000 kilowatt hours and a rate of about 12 cents a kilowatt hour at that time. So, it made an annual savings to their, fairly good sized dry cleaner of about $20,000, annually, just putting these drive controls properly in on multiple motors in the plant. This happened to be a 1,000,000 square foot complex that we had done, that originally they had said, okay, well, we have multiple motors in our building, but we've already put drive controls on. Well, we went in and did an audit on the building and found about another 75 motors in there that all needed controls in the right spot. So we were able to secure an incentive of about $305,000 for them, and about 1,785,000 kilowatt hours saved annually, about a $200,000 of annual savings, about $1 million over 5 years. So it's definitely worth a deep dive into your electric motors, and we have many partners around the world that can do the proper installation. We help get the review. This happened to be a water supply plant. Again, the same thing, secured a big incentive for them, and had a nice savings and had a very good return on investment. Metal finishing facility, same type of thing. Got just a few items in there that we did, but it had a nice return on investment. Let's see. Light facility. So the key is that the evaluation required to look at various applications. We have people and staff both here in America and also over in England that we can do a deep dive into the review of your electric motors. I have approximately 40 years in this industry, and Barnaby, one of my partners over in England, he has about 30, and works on a lot of very interesting machines and motors and applications, again, for proper energy savings. And like I said, we do that quick dive to determine what applications are best for you. Right out of the gate, we'll take a look at it and then let you know where you should dig deeper and what areas to find for your deep power savings. I also look a lot at the power bills. If you want to send me some of your power bills, just let me know that I won't share it with anybody else, but I will take a look at that, and you can tell on the power bill where your power factor is, where your total consumption is, when your demand is. So there's so you can get a real good understanding of what you're truly going to save. Not just put a VFD in as they're going to save you power, or like even in the pumping systems here in California, you need to look very hard at. For example, some of my customers, they had put some drive controls on certain pumps, but they found that they still, their power bills really didn't go down, because you need to look at total acre feet of water that you're getting onto the crop. And if you slow it down, it's going to do it at a little bit slower pace. And then also look at, the individual pump curves to determine the right spot for that. Again, some typical applications, that are out there. We've done a lot of work on ice rinks, a lot of hydraulic applications. So what we want to do is, to take a look at it is, some of the roadblocks that they found in the past is the upfront cost. Well, we have partners in the industry that will, fund these projects, 100%, and do it with zero capex, so you don't really require, capital to get them done. And then they'll do it, in a shared savings program over five years, and get it all implemented. Use the proper people all the way through down to the connection points, into your, if you have a very complex system, into your SCADA systems and control systems to get it fully integrated. And then also we check motor compatibility, to make sure motor compatibility is good. If it isn't, then we can also recommend, upgrading some of the motors to the right thing. And then we can get it, timely installed, so that you're not, a lot of people, okay, well, I'll put a few VFDs in. Well, you really don't see that incremental change in your total power bill as quick as you do when you basically do a complete review of your facility, and get that, that value figured out. So you want to take some time and assess, those individual applications. Where is it on flow? Where is it on pressure? Do some, the power companies require this anyway, that you need to look at the, pre-installed amount of power, that's required or is happening, and the savings, so that the numbers actually meet what you project, because the money that they're giving in incentives is coming back for deferring, having to increase other power plant expansions. And that's why they're investing the money now in energy conservation, not, necessarily wanting to build more and more power plants, because electric motors are such a high consumption of power. They really want to get these, under control. And the Department of Energy, EPRI, all of them have worked together and have, highly, researched over the years, because these were, developed clear back in the 70s and really got into implementation, in the early 90s and the heavy part, but there's still a lack of, application knowledge, and also make it so it's totally reliable. And so that's why I really try to utilize the keep it simple, attitude to, make it as simple as possible. So again, you want to, where it needs to be installed, the proper type of enclosures, are they got to be mounted away in an area? You got to be worried about the, ambient temperatures that they're running in, and dirt and dust, so that we, get a proper application. So what we recommend is also to take pictures of your nameplates, and your motors, so that you can determine, exactly what you've got going. And we can also determine then more the compatibility of the motor. So this happened to be enclosure with a totally exposed, air over motor. It gives us the frame size. We can look at the horsepower, look at the RPM and rating. And then if we also know, an idea of what it's operating, we can tell you what part of your power is, is running on what part of your facility as for energy. So it's not just, okay, I'm going to save, a big chunk of money. It's only if you have it applied to the proper applications properly. So these are some examples of a power plant that I retrofitted. These happen to be 750 horsepower medium voltage motors on boiler feed pumps going into a chip built or burning plant. and the draft fans, and these had a tremendous return on investment. We saved on average, I think they reduced their power consumption about $450,000 a year, and it's retrofitting about 40 motors in their plant. Also, there are differences in variable speed drives, in the quality, the type of transistors, the capability of what they can do, can't do, how they're compatible with your SCADA system or not. But don't be, always worried about, buying the top brand name. It's more important just understanding the quality that's inside. And if you want some feedback on that, I've worked and been into probably 10 or 15 variable frequency drive manufacturers around the world, all the way from China to England, to all of the United States, and have seen, over my career, how they're built, how they're designed. I was trained early on in the early 80s, benefit to a bunch of my friends that, helped a lot with Toshiba, back then. So again, back to the quality installations, reliable track record, and then get the proper airflows into there, and then get them so that they're programmed and tuned properly. This happened to be what I was talking about on the injection molding machines that I've done a lot of retrofits on, and we put the controls on, and instead of the hydraulic pump out here running full speed all the time, the system would actually pick up circuits inside where the process was and speed up and slow down the motor. So one project I did in Massachusetts, it was an optical lens company from around the world. They were dramatic. They had very long cure times. So the motor was sitting there running they had like a 4-minute cycle. So in that 4-minute cycle, they were really only truly using the clamp and the other part about 20% of the process. So it had a big return on investment, a lot of speed savings, plus it reduced the hydraulic cooling requirement that they were putting up to chillers on the roof. And so it actually saved a lot of money, operating the units. Some other benefits that they have is they do soft start and soft stop the motor. If you like, you can program that in, which eliminates issues on water hammer, surging into, piping systems. You can strategically do load control. So at different times of day on higher loads of big motors, you can actually slow the process down a little bit, get power savings that way, but also get, demand savings for the power company when we become more and more into, the demand of power around the world to do it. Some potential issues, originally they do have a, fairly high cost factor to purchase. Sometimes they're twice the price of the motor itself. But with the use of the incentives and then some of the strategic partners that I have that are, zero CapEx suppliers of funding, they'll actually help you with that and, allow you to offset some of that cost. Make sure you've got the proper control strategy in your control systems. Harmonics, which if you want to join me on the second, I'll go into more and more detail on that, so that you not only the input noise factors, the output noise factors, it's more on applications where you have multiple drives. A small number of drives isn't a real problem, but if you're putting all these on and that's back to that pulsing that goes into the drive and then the pulsing that goes out. The design characteristics of the motor, so that they actually integrate into a lot of the back nets out there, Profinet, DeviceNet. A lot of drives today have this capability. Let's see, the support, commissioning. This happened to be a system where it was put on with a BMS system, and so installed like 40 drives on a lot of their HVAC, and then we also integrated it into the BMS system, building management, and then we're able to, you can see, shave, with time of day, you can see the dramatic changes of total power consumption. Let's see. Then there's, a couple different types of incentives given by utility companies. There's what they call the prescriptive, which means like a Tylenol for the headache, I guess. But they know what kind of savings you're going to get on certain fans, pump, blower applications. Then there's a lot of funding available out there for custom applications, but it does require some pre-metering, some evaluation on the front side, and then do the calculations of power savings. And these can be fairly high incentives. Some power companies will give you as much as 50% of the cost here, and some of these go up to like 70% of the cost. And then the rest can also be, certain power companies will give you on the bill financing, where they'll actually, they'll provide the power or the funding for the projects and then do the offset by the adjustment, but you're getting the reduction in power. So it really doesn't change. Your bill actually goes down. They set it up that way with utilizing this technology. There are, a lot of low and medium voltage applications. We've done work in, motors up to, 500 horsepower in the 400 volt, machines, or 575. And then we've also done medium voltage machines, which are at more of the primary power, 4160 volt. And a lot of those are used in 750 horsepower and above. But there are, frequency controls. And then also we've been involved in the connection to the energy management systems. So again, it covers the, the common VFDs, quickly applied for, funding's available, discerned, and then you get fast turnaround on the funding, the funding for the projects. The dates are a little old on here, but this is some of the various types of, funding that were available from National Grid on the East Coast. And it does become a little bit daunting when you don't understand all of that they're asking for. So, please reach out, ask me, I can give you connections, into the Mass Saves program or into the variable speed drive programs that are run by the various power companies. And that goes somewhat around the world. I've got a lot of access. So you have to fill out, the company name, what it's for, what kind of project it is. And then these were some of the incentives that were given, for these various pieces of application. Sometimes it's, it's sizable money. A 60 horsepower was $8,250. But you also have to understand you've got to give this information because they will come out and typically audit after it's done to verify that you've achieved it. And then the custom applications are much more user specific, like chillers, air compressors. It's also dependent on actual applications that were utilized on conveyors, fans, and those things. That needs to be shown to them. It's a longer process of approval, takes some more data to be filled in and sent in, but it is available for energy savings. Again, I have access to a lot of the energy, renewable energy groups, the motor decision makers, and I want to thank you for attending. I can get long-winded. I've been going now about 45 minutes, but I do want to open it up for people to ask questions. And let's see here. So if you do want to email me at engineering@AC-DC-HOTLINE, this is my phone number. I'm also on WhatsApp, and please, reach out. So one person had mentioned, just go down to the bottom down there and put, any questions you have. And yeah, after I'm done, I will, send you a copy of the, the video of those that ask. Just send me an email. I'd be glad to send that, out to you. If you have any other, questions, please feel free to ask. If there's somebody else that jumped in. Yeah, I want to ask if we could get a copy of the recording. Yeah, I definitely will. The recording normally takes about a week to put it in, run it through, get it edited a little bit. But after that, I will, share it out to those people that actually, signed up, for it. And like I said, I'm a little bit more in my position today. I'm a little bit more semi-retired. I still love the industry. I love electric motors. Like I said, I was born inside. My dad started me winding when I was 10. And I really appreciate, people taking a look at it. But it is a spot. A lot of things are, people just don't know where they are or how they operate, or, if they could adjust them or not, or change them. I've retrofitted thousands of machines in my career, and glad to share, my experiences, and and then I've also belonged to a group called ESA, which is a worldwide organization of electric motor suppliers, installers, and my father used to be a chapter president of that group. And I go annually to their trade shows. Last year was in St. Louis. I have many friends there, and sometimes, the motor guy, he's a little bit more not real open about, wanting to, share some of the information. But the ESA people I found to be very, very, open to help you. And one person had asked a little bit more about harmonics, so I'll go into that a little bit further. So the power company has what they call IEEE 519, which was a standard that they created to make sure that the power on the input side doesn't filter back to other customers, because you'll get some noise here again where it spikes, and these spikes then go right back. They show up on this power line here because it's pulsing the power here, and so there's different, ways you can overcome that. But if you look at what your circuit is, what the transformer impedance is, and what the actual system is, whether it's a 6 pulse input, they have 12 pulse, 24 pulse. So it gets more pulse. So it actually is much easier on the input here. There's also third, fifth, and seventh harmonic filters that will, shave off, this so that you don't feed it back. That's what the power company is worried about, is that noise on the input. Then on the output, if you run anything over 100 feet, you need to really start being concerned about it, from where the VFD inverter, which is the same thing, is to the motor, and or if you have an older motor, to make sure that it has more spike resistant wire in it. There's also been a lot of things brought up about grounding rings inside the motor to make sure that you don't get circulating current. Part of that comes about is the tuning and the type of VFD that you have is one part of that. And also there's different types of transistors that various manufacturers use that have what they call peak shaving output, where it won't allow some of this surging to get out, to the motor. But there are various, filter requirements when you get into multiple drive applications. As a whole, it's important. It's not something you want to totally not, ignore. But an experienced drive guy that really has been in this for a while will be able to help you through some of those questions. And we have various suppliers that provide input filters and output filters, especially on submersible pump applications. You got a deep well, maybe down 200-300 feet where the motor is, so you get a lot of resonance. It can distort the wire, and the it's gone unchecked. and then over time, then you're pulling the pump out prematurely, and that's a no-no and very expensive. And then we have various manufacturers that we know of that have great motors that have special spike resistant wire and things that were built, in Germany that and have special types of film on them that also overcome some of those issues. So it's just knowing that when you're changing a circuit from what existing was, you're basically, the motor here before was just connected with a contactors turned on and off, and basically allowed to run up to full speed, whatever the sine wave was, try to get it to 65, but that's why you get a big surge in current and power. Well, that doesn't happen when we can regulate this and slowly ramp the voltage and frequency up to the motor. There also are, if you do have fixed speed machines that you don't want to, there are now out soft start devices which will do the soft start, and they just clip the waveform and they'll improve the power factor and make the motor run more efficient when you need fixed speed machines. There aren't as many incentives for that, but it definitely is a way. And I do give a class on all the various types of ways of starting running motors, controlling them with both VFDs, soft starts, old part winding starts. There's also ways of doing phase conversion, with these devices where you can just utilize 2 input phases, take single phase input, still build this DC, and then build true 3-phase out and run the motor. So we use a lot of these for, phase conversion also. We'll take a look at any other questions here. And a question, how often do we work with the water utilities? Do you have any protection done for evaluate treatment plants? I've worked a lot with treatment plants, both input and output. Both the fresh water and the wastewater. And so, especially on older plants, there's a lot of areas, even with, if you have aeration blowers and those types of things, there's an area there that might be very helpful to you. Yeah, and one person mentioned about the input filters do protect, the harmonic spikes into and then the output sine wave filter does help the output. And like I said, some people are sharing their emails here, and I'll be glad to review all that, later and, get that forward. I would like to open it up if anybody has any questions, they can unmute themselves and ask questions. I'd be glad to help out there if any way I can. I've got some time, I can still chat with you. Yeah, I thank everyone also I appreciate your kind words here. Thank you and your feedback about my presentation. I'm not a salesman. I'm here to explain to people, how to make a win-win application, out of putting controls in and implementing them properly on application. Again, Barnaby, he had a little bit of a conflict today, I think, because he got called away to a big project in England, so he wasn't able to, jump in as much as he would have liked to. But we do have, a lot of reach around the world. I've got, multiple, people around the world that I work with on a daily basis, and we do have a large supply of controls. We do inventory a lot of them, both from all the way down to fractional horsepower, all the way up to several hundred horsepower. We have many partnering agreements with some of the major manufacturers. I'm involved with a lot of motor manufacturing on both vertical hollow shafts, on submersible pump motors. I'm partners with a group out of Italy that we build very specialized submersible pumps for watering or for dewatering, for applications on, again, deep well submersibles, but also on desalinization, that they're properly designed. And I will be given another class probably end of February, first part of March, that I give. Oh, I have one that's coming up in February 2nd, which is specifically about, submersible pump motor application failure, deeper, deeper well application. But again, the issue is that we're dealing with a very large sector, and every dollar that we can save in, power here, or kilowatts or energy use here, we don't have to then have a power source. We don't have to have more wind, solar, nuclear, coal, whatever it is. We can shave this, and being that they consume 70% of the world's power, I feel if we could, reduce this, we can do it. I also see quite interesting that in Europe, power consumption is lower. Well, there's also one reason for that, is that the power there is they're providing a lot of it is 380 or 400 volt, 50 cycle power. So the same motor here in America will run on a 60 cycle power 480 volt. It'll run here, but the power consumption goes up dramatically because it speeds the pump curve. So a lot of machines are built for 50 cycle power, that they ship them here, they still work, but they consume more power. So my belief also, and I've actually, talked to EPRI and other people, we should consider in America slowing those generators down. If we slowed them down, they'd use less water, the total consumption of power would go back, and then the customers could ultimately go up a little bit more, with opening some of the dampers and flows. And there's more complex piece to that, but in essence, that's one big factor why, power consumption in Europe on some of the same applications is different. Let's see, I'll share, somebody asked if I share my email address, on the screen. I'll put it in the chat here quick. It's just engineering. I got it right. Yep. Okay, so it's just engineering at AC-DC-HOTLINE.com. And I watch that, regularly. I'm also very involved with LinkedIn. Link, as far as on LinkedIn, I do have a tremendous outreach. I have 30,000 LinkedIn members, and I've also have I belong to like 90 plus groups, which brings, thousands of people to my, my, events and information. And it really is it's a great, and it's a fun industry. I started having a winding coils when I was a kid, and there's just something about, I don't know, being a motor winder, early on, and then, then understanding the pieces. I was very fortunate with the university that I went to, and the college was a fairly small one, but I was able to connect with a mentor of mine, which was Curtis Reed. He was an amazing man. He took me aside because I had so much motor experience before I went to school from my dad. He took me aside and really took me on the deep dive, taught me a lot, shared a lot of the books that I have from Tesla, and a lot of the books that have gone for the, he was done with the IEEE, did a lot of things with them over the years. He used to be an IEEE engineer that, worked for many years on those groups, and, all around the world, and, sharing technology. And I think that's why I, started this group. And I do hope that a lot of people, join this, because it's really important that we, communicate, share information. The better we can share, the more we can actually, we can grow the technology, because, it was really brought forward in the, 90s and the 2000s really caught wind, but everybody gets lost a little bit in, branding, and then it's so many pieces of information that everybody has to try to, catch up to. And then a lot of the people that are, handling the controls, they don't necessarily understand all about electric motors. So when you understand motors extremely well about speed, torque, gearing, that's when you can actually accomplish a, win-win application. I have, many applications that I've installed, clear back in the, late 80s that are still running on processing machines that, sizing them properly, making sure that they run cool in the right environment, because they are an electronic device, but they become, so much smaller. I mean, some of the first ones I ever worked with from Toshiba, a 5 horsepower unit was in a 24-inch by 30-inch box by 20 inches deep, and nowadays you can get a 5 horse control, and it's in about a 6 by 6 by maybe a 5-inch cube, and will do the same thing, but also run a whole lot smoother and simpler, and than they did back then. There has been, some shortage with some of the things that are going around the world when some of the, getting access to some of the controls in a timely fashion. And I do highly also recommend, if you want, I can get you some access to some of the power research and utilization evaluations that were done on not only, my applications that I did on a Ford motor plant in Virginia back then, where we retrofitted like 40 machines and prove the savings, and then compared to other applications on fan pumps. I've got some of the portals and access with the Department of Energy that have also given some information. But again, when everybody has their day-to-day things that they have to work on or whatever, that's their expertise, and so they're trying to look at ways to get it so that it's implemented properly. But if you haven't done it every day, you don't understand maybe some of the terminology the power company's asking for, or the person that is telling you about the incentive may not have the experience on that given pump system. So then you go back to the manufacturer. Well, sometimes in there they have people that are representing to you the person that has the pump experience, but they maybe don't have all the electrical experience. So then they send you over the electrician and whatever. So one thing about it is I've been blessed with the opportunity to work on thousands of machines, thousands of VFDs. If I don't have the access to it or understand what it is, I've got the access to the partner or somebody that does know. And, we can give you references and people that really understand the technology. So, see, I think the chatting is pretty much done. Again, I want to thank everybody, and I appreciate all the, comments and the, information you passed along. I'll definitely, pull together pull together the video, chop out some of the,